The factor theorem states if x minus a is a factor of p of x, then p of a equals 0. Suppose if p of a is equal to 0, then we have x minus a as a factor. Okay. Also, we have several types of polynomials to factorize. What are the first available type of polynomial? It is linear polynomial. Okay. So, linear polynomial means it contains how many terms? It would be in the form ax plus b. Okay. So, this cannot be factored as this has only 2 terms. We can take any constant is out. If there is any constant, we can take that out. And there is another type of polynomial which is quadratic polynomial. That is in the form ax square plus bx plus c, where a should not be equal to 0. As this is quadratic polynomial, this can be factored as product of 2 linear factors. Product of how many linear factors? 2 linear factors. Unmute yourself and answer. Okay. So, let us say this is x minus p and x minus q. Likewise, 2 linear factor you can write, you can try to represent. Now, the third one is cubic. That is in the general form ax cube plus bx square plus cx plus d, in which a is not equal to 0. See, first of all, this can be represented as a product of a linear factor followed by some kx square, L will take lx square plus mx plus n. A linear factor and multiplied with the quadratic factor. This quadratic factor can be written as 2 linear factors. So, this can be written as x minus p, x minus q. Is that quite confusing, right? I will tell you once again. Given a type of polynomial, linear polynomial has only one expression. Okay. In that, either we can take constant out. We can't find any factors as in the form of x minus a, as said in the factor theorems form. And the quadratic polynomial can be factored as product of 2 linear factors. We don't know which is which. We have methods to find that and all. Cubic polynomial can be represented as product of a linear factor and a quadratic factor. And again, that quadratic factor can be separated as 3 linear factors. Okay. Clear? Okay. Now, how to find out these factors? There are 2 methods discussed in your book. The first one is by splitting the middle term. By splitting the middle term. And the next one by factor theorem. Usually, we will use splitting the middle term for this quadratic factor alone, and this factor theorem we may use for this cubic polynomial. Apart from that, how a cubic polynomial can be factored? See the last constant term. This may have several factors for that number. Okay, you should apply that one by one as a trial and error method. For any one value, it will get 0. After finding 1 0, by using a method called synthetic division, we can find the other 0. Okay, that is what we are telling it is by factor theorem. Factor theorem states what? If p of a is equals 0, then x minus a is a factor. How to find that value a? For that only we are investigating the factors of this constant term. Okay, we will get started with the example to get a better understanding. It's easy only, we can finish it off as quick as possible. Like quadratic one example, cubic one example, we will see, that is all. See, factorize six x square plus 17x plus 5 by splitting the middle term. If method is not mentioned, we can use any method. Suppose if the method is mentioned, we should use that method only. Okay, looks like I am singing a lullaby to one person, saying wow in the middle of the class. Not only small wow, it's a big wow. Like by splitting the middle term. Which one is called middle term? This one we should split. How this should be splitted means, the first and last number can be multiplied. 6 5s are 30. By multiplication 30, by addition 17. We should find two such numbers. Simply 15 2s are. Don't think of any shortcut method. We have to factorize this. We have to write every steps. Okay. So first we have to name the polynomial. Let p of x equals 6x square plus 17x plus 5. And after splitting this middle term, 6x square, this 17x can be splitted as 15x plus 2x plus 5. See, can you see the difference? That 17x is split into 2. And then we should try to group things. From the first two terms, anything is common and that can be taken out. 3x we can take out. If you take out 3x, then we have 2x plus 5. See here, 3 has been taken out means 2, x square x has been taken out means 6. So 2x plus 5 plus 2x plus 5. Now how many terms you are seeing? Initially we had 3 terms. We splitted and made that as 4 terms. And that 4 terms I taken common things from each 2. From this one can be taken out. So here how many terms? 2 terms. Yes, 2 terms are there. So from this anything is common means this 2x plus 5 is common. We will take that 2x plus 5. If 2x plus 5 goes out, then here 3x plus 1. So these are our linear factors of the given quadratic polynomial. Okay. Any doubts in this? So we should write p of x equals 2x plus 5, 3x plus 1. Okay. Next, factorize example 10. Factorize x cube minus 23x square plus 142x minus 120. See, we are going to solve this by factor theorem. The factor theorem, first step is to investigate the factors of the last constant term. So what are all the factors of 120? Minus 120 actually. So we will take plus or minus 1, plus or minus 2, plus or minus 3, 4, 5 and so on it goes up to at last plus or minus 120. Many things it is having. Okay. So in this, each one we need to check. Don't feel tired. Yes, actually each one we have to check. If you are lucky enough, you may get from these two pairs. Okay. So most probably it would be plus or minus 1 or plus or minus 2. That's all. 4 things you need to check. Also in many times you will get plus 1 or minus 1 as the factor. See, there are shortcuts are there also, but we will check by factor theorem. First we will take P of 1. What we will get for P of 1? 23 plus 142 minus 120. Okay. Then here 1 minus 23 is minus 22 plus 142 minus 120. So this 2 is subtracted, means 120 minus 120, it is 0. See how lucky we are. First itself we got 0. So we can say 1 is a factor. If 1 is a factor, then 1 is a 0. My bad. Then x minus 1 is a factor. Remember factor theorem, P of a is 0, then x minus a is factor. To find the other quadratic factor, we should reduce the power of the given polynomial by 1. Also, we should get a quadratic polynomial by doing synthetic division. Okay, how that will get? Remember I told you that cubic polynomials can be written as product of linear factor and quadratic factor. Is it or not? So that quadratic factor we are about to find. So first write the given polynomial and make sure that all the terms of the given polynomial is available or not, which means all the powers of x should be present. If anything is absent, use the coefficient of as for that missed thing as 0. Okay. So I will write this once again, x cube minus 23 x square plus 142x minus 120. X cube, x square, x power 0, everything is there. Write the coefficient of this 1 minus 23 plus 142 120, and we have 1 is a 0. So we will start dividing it by 1. Always it starts with a 0. You know this or not? Yes man, ask man. Yes. Minus 22 plus 22. See, minus 22 plus 142 is what? 120 minus 120. Okay. Any other thing? Okay, good. See, we'll start with the 0. It works like this. You know this, are you familiar with this method or not? Okay. So these two numbers should be added. 1 plus 0 is 0, right? 1. And we should multiply this. 1 ones are 1. Minus 22. Again this has to be these two has to be added, Rakanna. So minus 23 plus 1 is minus 22, and these two has to be multiplied once again. So 1 into minus 22 is minus 22. The answer has to be written here. This like it goes. Okay. So 142 minus 22 is 120. Okay. And then multiply means we will get 120. Okay. My bad. Here minus 120. Yes. I forgot to mention it is minus 120. Okay. Sorry for that. See, minus 120 plus 120 is 0. Any doubts in this? So, this method is called as synthetic division. What we got here is called as quotient. And this guy is called as remainder. And this person is called as divisor. Okay. So, it's a cubic polynomial. We have done synthetic division. Then it will reduce its power by 1. What we got as a quotient is the coefficient of x square. See, this is a coefficient of x square, this is a coefficient of x, and this is the constant term, coefficient of x power 0. So, the another factor is x square, 1 into x square minus 22 into x plus 120 into x power 0, that is 1. That is all. So, therefore, our p of x, we didn't name the polynomial yet, we will name it as p of x. So, our p of x can be written as x minus 1 into x square minus 22x plus 120. Okay. Now, it is easy to factor this, right? How we can factor this? By multiplication 120. Not solving, girl. We are doing factorization. We are not solving anything. What we are doing is, no, both are not same. Solving a polynomial is different. We can't solve a polynomial first of all. What we can do is, we can find zeros of a polynomial. Okay, unless it is an equation, we can't solve things. And solving is different, finding zeros is different, factorization is different. One comes after another. You got confused, right? See, man, to find zeros or to find the solution, the very first step is factorization. Once you find the factors, by equating the factors to 0, we can find the solution. So, this is first step only we are doing, we are not solving it. What you are doing is the very first step. Clear? See, by multiplication 120, addition minus 22. 10 times 12 obviously, minus 10 minus 12. Shall we? 28 Why 28? What 28? Hey, this is 22 da. I'll write 2 like this. That sounds like 8 to you. See? So, x minus 10 and x minus 12. That is all. These are the 3 factors. Which method? Yes, if they are asking us to solve by factor theorem, we will use factor theorem. But here that has to be mentioned. By factor theorem, 1 is a 0 of a polynomial. Then by factor theorem, x minus 1 is a factor. That has to be mentioned. Then by factor theorem, x minus 1 is a factor. Okay. Clear? Any doubts in this? I will repeat this process once again, or have you understood? If you want me to repeat this, tell me. See, given a cubic polynomial, we have to represent this that cubic polynomial as a product of linear factors. For that, we are going by the factor theorem. Factor theorem states what? If x minus a is a factor, p of a is 0. We don't have factor here, we need to find the factor. So, we will use the other other result of the factor theorem. If P of A is 0, then x minus A is a factor. What number we have to substitute? We don't know. For that, we are going to use the method called trial and error. You know, our life itself is a trial and error. We learn from our mistakes. We'll try something. If something is going wrong, means we'll come back and restart. That is what is called trial and error method. Likewise, here the factors of 120, that means the constant term, whatever number is there, be it 5, 1, 2, 60, whatever number comes here, you should find the factor for this. What are all the factors you list out? All the factors you should substitute, but for our good luck, either plus or minus 1 or plus or minus 2 will come as the answer. Okay. So, after getting a 0, then by factor theorem we have x minus that number as a factor. Then after that we will be doing the synthetic division. Before doing the synthetic division, we should make sure whether the quadratic, whether the given polynomial has all the terms of x or not, all the powers of x or not. X cube is present, x square is present, x is present, constant is present. Nothing is absent. If anything is absent, we put 0 as the coefficient of that. Suppose here x is not there, then plus 0x we should write, and that has to be written in the table. Okay, and 1 is a factor, means we are dividing that by 1. It always starts with the 0. 1 plus 0, this like we should add these two things. So 1 plus 0 is 1, and this has to be multiplied, answer has to be written in the other number, and that has to be added, and this answer has to be multiplied. This goes on until we get the remainder. What comes at last is remainder. What is in the quotient is whatever the polynomial you are doing. Like cubic polynomial means we will get quadratic here. Suppose we are dividing a biquadratic polynomial, power 4. Then here what you will get? Cubic. It will reduce the power 1. Okay, because the factor we are involving is linear factor. Okay, so we found the another quadratic factor. This quadratic factor also can be written as product of two linear factors. So we again solved it by splitting the middle term. Okay, clear? Shall we go to exercise? Okay. Yes. Two point. Oh, then actually completed. Okay, how about others class? Yeah, I think they are not doing this much of waste explanations, right? Okay, that is good thing only. Have they used the same synthetic division?